Hello students, in this video I am going to solve very important numericals in second BC chemistry board exam. This question is from solid state chapter. The question is the compound AXBY crystallizes in FCC lattice in which A occupies each corner of the cube and B occupies center of the each face of the cube. What is the formula of the compound? A is there in the corner and we know that there are 8 corner particles and for each corner particle contribution is 1 by 8, therefore it is equal to 1, correct? And B is there on the face center, they are present on the faces. You know that there are 6 faces are there and each face has a contribution of 1 by 2, therefore should be equal to 3, right? Therefore formula is A1 B3. Okay, this question is from solid state, an important question. The element having atomic mass 60 unified has FCC lattice. Edge length of the unit cell is 400 picometers. Calculate the density of the crystal. Avogadro number is given within brackets. If we require formula, density D is equal to Zm divided by A cube Na. Okay, and D stand for density. We need to calculate in terms of gram per cm cube. Remember the units also. Okay, Z is equal to number of particles per unit cell, in this case FCC. For FCC, Z is equal to 4. They are given the molar mass or atom mass is equal to 60 unified mass or gram per mole we can take. Okay, then they are given edge length is equal to 400 picometer. This 400 picometer should be converted to the centimeter. So this is a 400 into pico is equal to 10 power minus 12 meters, or these are 400 into 10 power minus 12 and 1 meter is equal to 100 centimeter, right? So therefore finally we can write 4 into 10 power minus 8 centimeter. Okay, so now in the formula D we are supposed to calculate density. Z is equal to 4 and molar mass is 60 divided by 4 into 10 to the power minus 8, then you have to cube it. This Avogadro number is given 6.022 into 10 power 23. Okay, so on substitution and finally using calculator, you can get the final answer is equal to 6.22 gram per cm cube comes. Okay, so remember you need to write the unit as well. So unit carry smart, so 6.22 here. Okay, right? Question number 3 from solid state. Metallic ion crystallizes in particular type cubic unit cell, not mentioned whether it is a simple cube, body centered cube, FCC. Okay, and the edge length is given A is equal to 287 picometers. The density is now given is equal to 7.87 gram per cm cube. Calculate the number of ion atom per unit cell. That means you are supposed to calculate Z value. Atomic mass is given 56, that is the molar mass. Avogadro number is given. So we have to calculate Z. So D is equal to Zm divided by A cube Na, correct? So D is equal to 7.87 given is equal to Z, you have to calculate into molar mass is 56 divided by A cube. This is equal to A is equal to 287 picometer, which is equal to 287 into 10 power minus 12 meter. So 287 into 10 power minus 2 into 10 power 2 centimeter, correct? So this is equal to 287 into 10 power minus 10 centimeter, or 2.87 into 10 power minus 8 centimeter. So I can write 2.87 into 10 to the power minus 8 cubit, correct? And Avogadro number is given. Avogadro number is equal to 6.023 into 10 power 23. So calculate that value. That value comes to be equal to 2. Okay, that means then when Z is equal to, it is a BCC. Okay. So for BCC that is equal to, and for FCC that is equal to 4, you have to remember. Okay, right? Clear? Question number 4 is from the solution chapter, and this is based on the elevation of the boiling point. Where boiling point is mentioned here. Boiling point of benzene is given when 1.80 gram of non-volatile solute dissolved in 90 grams of benzene, boiling point was increased. Calculate the molar mass solute and Kb is given. So you have to remember the formula delta Tb, elevation boiling point is equal to 1000 Kb into W2 divided by W1 into molar mass of the solute. So we'll calculate what is the delta Tb difference. The difference is 354.11 minus 353.23. This comes to be 0.88 Kelvin. Okay, so that is equal to 0.88 is equal to 1000 into Kb value is given in the question itself 2.53 into W2. W2 is the weight of the solute dissolved, that is 1.80 divided by W1. W1 is the weight of the solvent. Okay, W1 that is the 90 grams given into the molar mass we are supposed to calculate. So on calculation this molar mass comes to be 57.5, and what is the unit of molar mass? It should be in terms of gram per mole. Okay, right? Question number 5 is from solution chapter and based on the depression, the freezing point concept. Okay, 0.643 gram of compound dissolved in 50 ml of liquid, density is given, weight of the solvent is not given, we can calculate using density formula, and the freezing point was lowered from 5.51 degrees centigrade to 5.03 degrees centigrade. Calculate molar mass. Similar formula, delta Tf is equal to 1000 Kf into W2 divided by W1 into molar mass M2. Let us calculate difference in the freezing point. So it is a 5.51 minus 5.03, that is equal to 0.48 difference. Okay, so let me write here. So there is 0.48 is equal to 1000 into Kf is given in brackets 5.12 into W2. This is a W2, weight of the solute dissolved, W2. So this W2 is equal to 0.643 divided by molar mass you have to calculate into W1. Weight of the solvent is not given directly, but we can calculate using formula density is equal to mass divided by volume. So therefore mass is equal to density into volume, correct? So we'll get in some grams only. So density is given 0.879 into volume is 50 ml. So that ml get cancelled. So write to the grams now. So it is 43.75 gram comes. So divided by 43.75 grams. So on calculation of molar mass comes to be 156, and after this you have to write down gram per mole as the unit. Okay, clear? Now this is the question from the electrochemistry based on the DNA cell, and we have to calculate Gibbs free energy. Okay, Gibbs free energy you have to calculate, and electrode potential is given 1.1 volt, and equations given, and Faraday value is also mentioned. So what is the formula to calculate standard Gibbs free energy? So we have the formula delta G naught is equal to minus NF E naught cell. Okay, E naught cell. So is equal to what is n is nothing but number electron transferred. So what is the overall equation? Overall equation like this: zinc reacts with the copper 2 plus from copper sulfate to give zinc 2 plus ions and become copper deposited. So n value is equal to 2 electrons are lost, 2 electrons are gained. So 2 into Faraday's constant given 96,487 coulomb per mole into E naught cell given in the question itself 1.1 mole. So this answer to be comes to be minus 212,271.4 unit of Gibbs free energy in terms of joules you can write. So minus 212.271 in terms of kilojoules can also be written. Okay, right? This question is from electrochemistry based on the EMF of the cell, and you have to make is a Nernst equation here. calculate m of the cell for the cell given, and individual SRP values are given for magnesium and silver is given, concentration magnesium given, and that silver is given. So what is the Nernst equation? Nernst equation is equal to E is equal to E cell is equal to E naught cell minus 0.0591 divided by n value log of, in terms of anode and cathode, I can write anode concentration divided by cathode concentration, or also you can write in terms of product divided by reactant concentration. Now what is the anode here? Magnesium undergoes oxidation, correct? So magnesium become magnesium 2 plus. So magnesium is the anode here actually. Magnesium is the anode, okay? And silver plus 1 becomes silver. So silver is the cathode. At cathode reduction take place, you have to remember, okay? Right? Now what is the n value here? N value is equal to magnesium 2 plus and silver plus 1 into 2, right? So 2 electrons are lost and 2 electron gained. So 2 n is equal to 2, okay? But how to calculate E naught cell? E naught cell is equal to, remember, E naught of the cathode minus E naught of the anode, which is equal to E naught of the cathode, cathode is silver, minus E naught of the anode, anode is magnesium, correct? And their SRP values are given. So it is a 0.8 minus of minus 2.37. This comes to be equal to 3.17 volt, right? 377 volt, right? Now substitute in the formula. E cell is equal to E naught 3.17 minus 0.0591 divided by 2 here, correct? Log of anode. Anode is magnesium. Magnesium is given. This is the 10 power minus 3, correct? So I can write this as the 10 power minus 3 and this I can write as the 10 power minus 4, correct? So this is 10 power minus 3 divided by, so we have got 10 power minus 4. Now see here, this is the magnesium 2 plus concentration divided by Ag plus concentration, correct? But number of moles, okay, 2 for silver, right? Silver, so you have to square it. So see the powers, power is plus 2 here, plus 1 into 2, this number should be same. That should be equivalent to the 2, n is equal to. Power should be same here. So you have to square actually, okay? So now this is equal to 10 power minus 3 divided by 10 power minus 8, but this is equal to 10 power plus 5, right? And log 10 power plus 5 is given is equal to 5. So we can directly substitute there. So this would be equal to 3.17 minus 0.0591 divided by 2, then this log of 5 actually, correct? So this is equal to 3.17 minus 0.0591 divided by 2 log 10 to the power 5 should be. So 10 power 5 is equal to 5. So final answer is equal to 3.0225 volt it comes. Remember, so you write the answer in terms of volt here. Okay, this is the final answer. Clear? Question number 8 is based on the electrochemistry chapter and about the conductivity and resistance of these solutions. The resistance of the conductivity cell containing 0.001 molar KCl is given 1500 ohms. That means concentration given is equal to 0.001 molar and its resistance is equal to 1500 ohms are given. What is the cell constant? You have calculated cell constant. What is cell constant? Cell constant is nothing but G star. We are supposed to calculate. And if the conductivity of the same solution is conductivity symbol kappa K, I can write. So 0.416 into 10 power minus 3 into Simon centimeter inverse. Okay. So what is the formula? So formula is the G star is equal to RK. You can make use of directly. So R is equal to 1500 in terms of ohms and the conductivity kappa is a 0.146 into 10 power minus 3 Simon and centimeter inverse. The Simon actually nothing but ohm inverse, that means ohm inverse and ohm get cancelled, so it is equal to 1500 into 0.416 in terms of centimeter inverse, 10 power minus 2 centimeter inverse, correct? um, so this is given 10 power minus 3 here, 10 power minus in the question, 10 power minus 3, 10 power minus 3. So this product would be equal to 219 into 10 power minus 3 centimeter inverse, or I can also write 2.19 into 10 power minus 5 centimeter inverse. Okay, yeah. Question number 9 is based on half-life in the chemical kinetics. Half-life first order reaction you have to calculate. If the rate constant is given, yeah. What the formula? Simple formula. Half-life T half is equal to, for first order, 0.693 divided by rate constant K. So it is equal to 0.693 divided by K value is given here. 6.93 into 10 power minus 3 in terms of second inverse. Okay. So this is equal to 10 power minus 1, it become 0.1, and this goes to numerator, become 10 power plus 3 second inverse. The second inverse become second, so it is equal to 10 power 2 second or 100 seconds. It is correct, right? So remember this formula, T half is equal to 0.690 divided by K. Question number 10 is based in the chemical kinetics chapter, and you have to calculate the average rate. They are given the reaction giving the reactant giving the product. Concentration reactant changes from 0.03 to 0.02 in 25 minutes, and you have to calculate the average rate into seconds. So how to calculate the rate? Rate is equal to, so this is the R giving P, so therefore it is equal to minus, with respect to reactant it should be minus, okay, then change in concentration of the reactant divided by time interval dt. So minus change in concentration final minus initial 0.03 minus 0.02 final minus 0.03 initial divided by time interval 25 minutes are given, convert into seconds now, so it is into 60 to do. So this is equal to plus 0.01 divided by 25 into 60. Okay, so this will be in terms of now seconds divided by second, but the rate will be in terms of, this is the concentration of mole per liter, and now this is in terms of seconds. Okay, so the final answer is equal to, so 6.66 into 10 power minus 6. Okay, so I've written in terms of scientific notation. Otherwise, it comes to be like 0.000666 into 10 power minus 2 comes. So this is a change into the scientific notation. The final unit is a mole per liter per second it becomes. Okay. Yeah, the last question is from again kinetics, similar question. 2A giving the product now. Concentration decreases 0.5 to 0.4 in 10 minutes. Calculate the rate during the time interval. We are not going to change the unit now. Let the minute be minute only, not going to convert into seconds now. Okay. So they are given 2A giving the product. Okay. So outright the rate. Rate is equal to minus. Now there are 2 moles are there per mole. 1 by 2 you have to do into change in concentration of the reactant A divided by the time interval dt. So minus 1 by 2. So difference in concentration is a final minus initial divided by time interval in terms of minutes only 10. So this is equal to plus 0.1 divided by 50. So this will be equal to 5 into 10 power minus 3. So rate you know that mole per liter in terms of now minute inverse you are given. Okay, right? Yes. So these are the few important problems which can appear in the board's examination. Thank you for watching. Have a nice day.